back. Today we're going to be talking about solving systems of equations using substitution. Let's go ahead and talk about what a system is. So what is a system? A system is two or more equations that have the same variables. We will be solving for both variables, or all three in some cases, to determine the solution to the system. Now let's take a look at how we're going to do that. So here are our steps for solving using substitution. Step one, we're going to choose one equation and isolate either the x or y variable if needed. Then we're going to substitute in the equation for the variable in the second equation. Then we're going to solve that equation and use our answer to solve for the remaining unknown value. Now let's put that into practice by taking a look at example A. So here we are in example A, and it says solve for x and y, and we need to write our answer as an ordered pair. That's important. We're going to need both x and y when we're done. So we can see we've got two equations there, 2x plus 3y equals 31, and y equals x plus 7. So this is a system because we have two equations there, but they're going to be the same x and y. So we're going to use substitution. So we're going to plug in one of the equations for one of the variables. In this case, we've got y equals x plus 7. It's already isolated for us, so that makes it easy for us to substitute in. We know that y equals x plus 7. So in our equation above that, we can plug y in the x plus 7 that we know y stands for x plus 7. So let's go ahead and substitute that in now and see how that looks. So we've got 2x. We're going to plug in the x plus 7 for y, so x plus 7, we're going to substitute it, then equals 31. We're now going to solve our equation, so we're going to do that and we do things that we've learned before. So we're going to distribute. We've got 2x is then going to equal 3x plus 3x plus 21 equals 31. Now it's time to draw our wall. So we're going to draw our wall. We're going to combine our like terms. We've got 5x over here plus 21 equals 31. Then we're going to subtract that 21 on both sides. So minus 21 here, minus 21 here. And we end up with 5x equals 10. And then our final step is going to be divide both sides by 5, and we get x equals 2. And that's great. We've got x equals 2. And that's part of our ordered pair. Remember, an ordered pair has to have both an x and a y. So we know that 2 is our x. So now we're going to substitute that 2 back into either one of our equations in order to figure out the y. The easiest one to plug it into is the y equals x plus 7, because we won't have to do that much math. So if we plug that in, we've got y, plug in the 2 that we just got, plus 7. 2 plus 7 is 9, so we get y is equal to 9. So we know that our ordered pair is 2, 9. That will also work if you plug the 2 into the other equation and do 2 times 2 plus 3y equals 31 and solve that equation to get 9. But you can pick either one, and we pick the easier of the ones to use. Now let's take a look at example B. Here we are at example B, and again it says solve for x and y and write our answer as an ordered pair. So this time, unfortunately, neither of our variables on either one of our equations has been isolated. We have y minus x, so those variables are together, and 12x minus 5y, those variables are together. So we have to choose one to isolate. It's the easiest thing to do to take that x away from the top example. So if we have y minus x equals 2, we can just very easily add the x to the other side. So we're going to add x to both sides, and we end up with y is equal to x plus 2. That's an easy way to isolate the variable. We've got y isolated, but you could isolate any variable on either equation to make this work. So now that we have y equals x plus 2, it's time to do some substitution. So we're going to substitute the y into the second equation that we have there. So we've got 12x minus 5, and we're going to substitute x plus 2 for the y, because that's what we figured out y to be, equal to negative 24. So now that we've done that, it's time to solve our equation. So we're going to go ahead and distribute. So we've got negative 5 times x and negative 5 times positive 2. When we do that, we get 12x minus 5x minus 10, because a positive times a negative is a negative, and we get negative 24. Now it's time to combine our like terms. So we're going to combine our x's. So we've got 12x and negative 5x. Those are going to give me positive 7x. 7x minus 10 is equal to negative 24. And now we've got a regular two-step equation that we had to solve, so we draw our wall. We're going to add 10 to both sides. When we do that, we get negative 14 over here. We get 7x over here. And our final step is to divide both sides by 7. So divide by 7, divide by 7. 7 divided by 7 is 1, or 1x. Negative 14 divided by 7 is negative 2. So now we know that x is equal to negative 2, and that's one part of our ordered pair. But we have to substitute it back in order to figure out what y is going to be. And again, you can substitute it into whichever equation you want to. I'm going to pick the y minus x one because that's going to be a lot easier for us to do. But we can, of course, pick whichever one we'd like. So I'm going to substitute in, we're going to get y minus negative 2 equals positive 2. Now we've got to do a minus and a minus, so that's going to be plus. So we're going to end up with y plus 2 equals 2. So now our final step is going to be able to draw our wall. We're going to subtract 2 on both sides. These are going to cancel. We're going to end up with y equals 0. So we got 0 as our second part of our ordered pair, and we now have our answer. Now let's take a look at example C. Here we are at example C, and it says solve for x and y, write your answer as an ordered pair. So here we've got our two equations, but bad news, none of our variables have been isolated, and it's not going to be easy to get one of our variables isolated. So again, we could pick either one that we want, either x or y, on either one of the equations. But I can see from that second equation that moving 7 around or dividing by 7 is not going to be a lot of fun, so I'm going to try and avoid that. So I've got negative 2x plus 6y, so that's the route I'm going to go. I'm going to go isolate the x this time because we've isolated the y many times, so we've seen that in action. So this time we're going to isolate the x. So to make that happen, we've got negative 2x plus 6y is equal to 6. So we're going to move the 6y by subtracting 6y on both sides. So minus 6y here, minus 6y here. These are going to cancel. Leave me with negative 2x is going to be equal to negative 6y plus 6. Divide both sides by negative 2. Negative 2, negative 2, negative 2. These are going to cancel. Leave me with x is going to give me positive 3y and negative 3. So now I have x isolated, so I can substitute that back into the other equation that I did not use. So I'm going to have negative 7 parentheses because I'm going to be plugging into the x this time. So I've got to have 3y minus 3, close parentheses, then we're going to add 8y, and we're going to get negative 5 on the other side. Now it's time to solve our equation, so we're going to start by a distributing property. So we're going to distribute negative 7 to 3 and negative 7 to negative 3. So negative 7 times negative 3y is going to be negative 21y. Negative 3 times negative 7 is going to be positive 21. Bring down the 8y is equal to negative 5. Now it's time to combine some like terms. So we're going to combine our negative 21y and our positive 8y. That's going to give us negative 13y. Negative 13y plus 21 going to be equal to negative 5. Then we're going to subtract 21 on both sides. Do that now. Minus 21, minus 21. These are going to cancel. Leave me with 13y is going to be equal to negative 26. And my last step is going to be to divide both sides by 13. And when I do that, I get y is equal to negative 2. So I've got y equal to negative 2, not negative 21, negative 2. So that is one of the points in our ordered pair. So we know the y now is negative 2. So now I have to substitute that back in for x, and again, substitute the negative 2 into either equation. It doesn't matter which one. We'll substitute for y here in the top equation, but again, you could pick either one that you wanted to. So we're going to plug in negative 2x plus 6 parentheses negative 2 is equal to positive 6. Now we need to go about solving that equation. So we're going to do 2x, need a pen here, 2x. 6 times negative 2 is going to give me negative 12. Equal to 6. So we're going to draw our wall. Now we've got a regular two-step equation. We're going to add 12 to both sides. These are going to cancel, leaving me with 2x equals 18. My final step is to divide both sides by 2, and I get x is equal to 9. So that is my other point. So I've got 9, negative 2 as my ordered pair. That brings us to the end of this problem. It also brings us to the end of this set of notes and this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.